Okay, today's lesson is 74, simplifying square roots. What's our objective, class? Get ready?
Simplifying square roots.
Simplifying square roots. We've already worked with square roots when we've had answers like hypotenuses that are like root 20 units long. Today we're going to talk about that there's a simpler way to write square roots, especially big ones. We want to write them in the simplest way possible. So let me introduce it by this. If I had 2 plus 2 plus 2 equals 3 times, sorry, there's 3 2's. So I could say that that's the same as 3 times 2. If I had 3 radicals, these are also called radicals, but root 2 plus root 2 plus root 2, I have 3 of them, so I would say I have 3 root 2's. So that same principle can help us multiply. When we have 2 radicals, if they're both under a radical, there's a cool property that allows us to combine them under one radical. So I can actually say this is the same as root 2 times 6. What does that allow me to do? It allows me to go ahead and multiply and make it more simple, which would be root 12. I can go in reverse as well. If I started with root 12, I could say, hey, that's the same as 6 times 2, which I can now split that up and make it root 6 times root 2. So I guess the difference with the first example, if it's a coefficient, it has to stay outside of the radical. If it's inside the radical, we can combine them into one. So I bet some of you are thinking, does it have to be a 6 and a 2? What would it be, Jasmine?
I was going to ask if it could be 3 and 4.
Let's find out. She's absolutely right. It says 12, so I have other factors. Could I split those up and say root 3 times root 4? Don't I know root 4? I do. What does root 4 think? Get ready?
2.
2. So really this is root 3 times 2. We like the coefficient in front, so I'm going to rewrite it with the coefficient in front. That way I don't get confused. Is this inside or outside? And the answer is 2 root 3. So this is the simplified version of root 12. From henceforth, whenever you give me a radical answer, you have to check, do any of the factors have a square root that I could take? If it does, you must take the square root and write it in simplest form. So we're going to practice a whole bunch today. First, the property says the square root of 2 factors is equal to the square root of each factor multiplied. So this is the product property of square root. Square root of AB equals square root of A times root B. Jasmine?
So it's basically the distributive property, but with square roots?
I guess kind of. There's just no addition or subtraction. That's the difference, okay? So let's try root 18 first. I need to think of factors of 18, and I'm specifically looking for factors that I could take the square root of. Emma?
6 and 3.
6 and 3. Okay. Neither of those I can take the square root of, but there are certainly factors. Hannah? 9 and 2. Ah, I'm liking the 9 because I can take the square root of 9. So let's do this. Let's rewrite root 18. I like this one better as 9 times 2. The product property says I can split them up into 2 radicals, still multiplying by each other. Root 9 is, think. Okay, ready?
3.
3. And look, I took the square root. It's just 3. So don't be writing another square root over that. It's just 3. And copy that down. Simplified answer. Let's try root 600. I need some factors of 600. Connor.
160.
160. Well, how about just a 6? Okay. What else? I got some other choices too. Emma?
302.
302. Jasmine?
60 and 10.
60 and 10. These are all great. Liesel?
203.
203. And how about let's stop there? One of these is better than the rest because I can take the square root of one of those numbers. Which one's the best one? Colin?
First one.
The first one. Okay, which I can take the square root of 100. I can't take the square root of that. I can't easily, and I'd have to play with it a little bit. I can play with the 200. But that one, right off the bat, I know the square root of 100, so let's work with that. So this becomes the square root of 100 times 6. I work vertically. I split that up into 2 radicals, and I can take the square root of 100, which is, think. Get ready?
10.
10. You guys are totally with me. Thank you. And that's the simplest way to write it. 1, 2, 3 steps in root 6 doesn't simplify anymore. Let's say I had this one because I just couldn't think of the 100. Let's say I was trying the 200 times 3. Okay? I'd have to still factor the 200, right? I can do that. Maybe I tried 40 and 5, and I've still got this 3. Whew. Okay, I still don't have something I can square root of, but I've got a 4, a 10. I've still got the 5 and the 3. Whew. Okay, so now let's see, I put it all in there. I got a 4, a 10, a 5, and a 3. The only thing I can take the square root of right here is the 4. So I could do that. I'm getting lots of steps here. Root 4, root 10, root 5, root 3. That's a 2. You know what, that can factor. 2 and 5. Wait a minute, I got another 5. Oh, okay, let's put these 5s under one radical. 2, root 2, root 5 times 5, root 3. 2, root 2, root 25, root 3. What's the root of 25? Think. Get ready?
5.
5. So I have 2, root 2. This is a 5, root 3. I'm just going to put my coefficients together. So 10. Now I have root 2, root 3. They're both primes, so they're not going to have any other perfect squares. So I'm going to just combine them to get 10 root 2 times 3, which is 6. Holy moly. 1, 2, 3 steps because I found the 100. I couldn't see the 100 here, so I made it really hard. And I did 1, 2, 3, 4, 5, 6, 7, 8, 9 steps. Okay, so we've just learned, if you can find a perfect square, it's easier. What are perfect squares? What's a perfect square? Connor?
Anything that has a square root times itself.
Anything that has a square root. I never times itself. 4, 9, 16, 25, 36, 49. Look it down the diagonal of your multiplication chart. Those are your perfect squares. So those are numbers you're going to test. Hey, your turn. Try 216. And then I had a hand up. Whose question was that? Jasmine.
I was just curious, with the 200, to make it simpler, could you say,
100
instead of doing 200 times 3, could you do 100 times 2 times 3 and then just times 3?
Yes.
It's easier just to do 100
Yes.
times
I
3.
purposely made it super hard and long so you don't do it that way. So it would be better to find your 100 right off the bat. Okay, I'm going to push pause in a second, but I want you to factor this. Put your pencil up when you've got it factored and simplified. Okay, we gave you some time to work. Annika, what did you get?
I got 6.
How many of you got 6 root 6? So about 3/4 of the class, not everybody, because some of you got stuck on the number 24. Here's what I saw. What was your factor that had a 24 in it? Was it 9?
Yeah.
So you got 9 and 24. So let's take the square root of both of those. Split them up now. Root 9, root 24. Well, you can take the square root of that. That gives you 3. And then you got stuck right here going, am I done? So does this have factors? You got 12 and 2, but it's not going to help us because 12 doesn't have a root. Hannah? 4 and 6. 6 doesn't have any square roots, but 4 does. So we're going to split this up like that. Take the radical of each term. And don't forget about your 3, so I'm going to copy it down there. Root 4 is 2. So I really have 3 times 2 times root 6. 3 times 2 is 6 times root 6. So there's a way. That looks like a heart. Okay, Emma.
An easier way to do it is just 36, or root 36 and then 6, because root 36 is 6, so just...
Okay, and you know what I do, because I've done these a lot, I've had lots more practice than you guys. Whatever my perfect square is, I always write it first, because then I know the order is already in order. I go like this, ding, and it's already in order. I don't have to switch the order. So I always put my perfect square first. All right, what if you get some weird number like root 210, and you go through and you check, gosh, is this, if you got a calculator, check it. Is it divisible by 4? Is it divisible by 9? How about 16? Just checking some of the first few perfect squares. Is it divisible by any of those? Connor?
I got like a 5.
It's divisible by 5, but that's not gonna help us. We need something we could take the square root of. So you could just plug and like try all of the main ones up to, gosh, what would it, gosh, you'd have to go that high. 49 would be the highest you'd have to go to, even less than that. And then none of these are factors, so guess what? It doesn't have any way to simplify. So the answer is root 210. That's the most simple way to write that one. Okay? Okay, let's try one practical problem. You're going to like this because it's going to tie into an older lesson too. Arnold, he wants to walk from point A to point B, but he doesn't want to go like down, around the block and around the building because it's 100 plus 100. So he wants to cut through, and he wants to find out, well, how much shorter is it? So what's the distance here? So we go, oh yeah, right triangle, leg squared, hypotenuse squared. Pythagorean's theorem. So we square the 100, we get a 1 with 4 zeros, and another 1 with 4 zeros. And we add the two together, we get 20,000 equals c squared. Well, Arnold doesn't want to know what c squared is. He wants to know what c is. How do I get rid of the squared? This is old stuff. Rachel? Take the square root. Cancels. We're left with c. Square root of 20,000. We said from now on we can't leave big numbers and radicals. We have to check it to see if it has factors. If you see lots of zeros, you know 100's going to work, right? So let's factor it into 100, and this is going to take off 2 of the zeros. That leaves us with 200. And can't I do the 200 trick we kind of, Jasmine taught before? Can't we make that 2 and 100? You bet. I'm going to list the perfect squares first, right? Square root all of it. Now square root each one. I'm going to do shortcut. Right? Give me a nod if you're okay so far. Okay? So root 100 is 10, root 100 is 10, root 2, we leave it, it doesn't have a root, and we combine 10 times 10 is 100, root 2. This is the most simple way to write the length he has to walk. Question, if these two legs are the same, what kind of angles do I have here? Joseph.
45 degrees.
Oh, you're so smart. 45. If I have a 45, 45, 90, I have leg, and hypotenuse. So I got 100, 100, 100 root 2. Who remembers x root 2?
Wow.
Okay, so 45, 45, 90, your pattern is x root 2. Keep that in mind. Okay, well, that'll come back. All right, any questions on the lesson? Hannah?
Also, if we are doing one of those triangles, we have to write all the steps of
If you see the 45, 45, 90, you have the privilege to go right to that. Okay? If you don't, and you have root 20,000, you have to do those steps. Right there. All right, we're on page, I think, I want to say 499. Oh, 499.
Yeah.
Okay.